Hi, ninth period. It's that time again. Unfortunately, I'm out for another appointment. So you guys are going to listen to Mr. Lane today and follow along with this video to try to get a little bit of work done while I'm out. I know you guys will treat Mr. Lane with the utmost respect, and if not, he knows exactly what to do and how to punish you. Hopefully not physically, but I mean, who knows? You have my permission, Mr. Lane. You guys have about 3 minutes to get started on the bell ringer. Sorry, 3 minutes to finish the bell ringer, and then we'll get started. You have about 30 seconds left to finish the question. All right, so when we're looking at the bell ringer here, you first have to determine the number of valence electrons that are around the mystery element. So if you're looking at the mystery element, you can see there's 7 electrons, 1, 2, 3, 4, 5, 6, 7. Now that you know that there's 7 electrons, you have to find the group that would have 7 electrons. In this case, that group should be group 17. So if group 17 is the mystery elements group, then you should know the name of that group. So this question is testing a couple different things. First of all, do you know how to find valence electrons? And then second of all, do you know what the groups are called? On the common assessment and on the unit test, this is an easy way to gain a lot of points, is just by knowing your groups really well. I haven't found a question that's phrased this way that is hard. All the questions about the groups seem to be pretty easy, and if you know them, you'll get them right. In this case, group 17 is the halogens. So hopefully most of you knew that the halogens were group 17. The alkali metals are group 1, alkali earth are group 2, and the noble gases are group 18. The transition metals are all of the D block, so from group 3 to 12. I'm going to give you about a minute. I need you to take out your notes from yesterday, so that's the single sheet that has the Lewis structures on them, and I need you to take out your packet on page 33. So that's your notes from yesterday, the single sheet that was not part of the packet, and then your packet on page 33. If you've lost the single sheet, I made some extra copies. They're on the side counter. So Mr. Lane, they should be labeled for Mr. Lane. So if you need an extra, you guys have 1 minute. Go. Thank you, Paulina and Jasmine, for having your notes out, and Alondra. Thank you, Carol, for being organized. I can see that you have your stuff out. Still waiting on Ashley. No, I'm just kidding. I can't see y'all, guys. Okay, hopefully you have your notes out at this point. Just what we're doing today, you guys are going to learn how to do the Lewis structures for polyatomic ions and as well for exceptions. It's pretty quick. It's pretty easy. You guys will have a bit of time to practice, maybe 5 or 10 minutes. And then at the end, we're going to take an exit ticket. Just by judging the other class periods today, the exit ticket is not going to be for a grade. It's been a bit of a mess. So we'll practice those more tomorrow, and then we'll move forward to shapes. If you feel like you're ready for Lewis dots or for shapes tomorrow, I'll have an extension activity for you. There's no homework tonight, but remember the Unit 8 test is next Wednesday and Thursday. I do not have tutorials after school today, obviously, like I normally do, but I will have them on Monday at lunch and then Tuesday after school to make up for missing tutorials. My apologies for the scheduling. Let's move forward. I want you to look at the notes from yesterday at the bottom where you'll see an example for cyanide. We did not do that example in class, so we're going to talk about the cyanide ion now. I'm going to drag a YouTube video that I found about how to draw the cyanide ion into the video, or into the screen here. Oh, let me size it right. And then I'm going to narrate over, because the guy narrating goes into a little more detail than we go into, and also he's kind of boring and I'm super interesting. So let's take a look. You can see cyanide is the Cn with a charge of -1. You can find this on the back of your periodic table, and right now he's finding the number of electrons that there is. So you might be a little confused by that extra 1 at the end. Carbon, of course, is in group 14, so that's why there's 4. Nitrogen is in group 5, so that's why there's 5. And then the -1 sign, that -1 means there's an extra electron, so that's why it is a +1 afterwards. So if it was just Cn, you would only have 9, but because of that -1, you have to add that extra electron on to give it 10. All right, let's continue on. So you have 10 total electrons. He goes really fast too, so I'm going to try to keep up. But you're going to draw your C and your end. Of course, he already has a single bond there. Okay, so that's going to be 2 electrons, so only has 8 left to work with. He's talking about single bonds. Okay, he tries to make carbon happy first with the lone pairs. So now with the single bond and the carbons, and the lone pairs on the carbon, that's 6 plus 2 plus 2. That's all the electrons you have, okay? Once you're out of electrons, you have to go back and you have to make a double bond. So there's no electrons here. So he crosses off the lone pair, adds a double bond. Nitrogen's still not happy. Nitrogen only has 6. Carbon's happy with 8, but nitrogen needs 2 more. So you're going to take another lone pair from carbon, and you're going to add a triple bond, okay? So cyanide actually has a triple bond where carbon and nitrogen are sharing 6 electrons in the middle. Remember, each of the lines represents 2 electrons. So those 3 lines are 6 electrons. And then carbon and nitrogen both have a lone pair on them, so that they will both have 8. Okay. I don't know why I'm still playing this. I'm done with him. Okay, let me find the next video. All right, so the next ion we're going to talk about is sulfite. So I got another video for that. I'm going to drag that in. Again, I have to resize it. Okay, and I'm going to do the same kind of thing. All right, so we have the sulfide ion. By the way, if you ever want to figure out how to do Lewis dot of anything, go to YouTube. There's every single example I've ever tried to find is on YouTube. I don't know who this guy is, but he sure does love Lewis dots. All right, so we have sulfide ion here. And again, we're taking count. So 6 for the sulfur, 3 times 6 for oxygen. And then because of that -2, right, how many extra electrons should I add? Ezekiel? Hopefully he's paying attention, or maybe I hope he's here today, and he said 2. All right, so that would be 24 plus 2, 26 total. So now he's going to draw the sulfur in the middle. He's drawing his single bonds with the oxygens. We're going to try to make all of them happy. So right there, right here, he's used 18 electrons for the 3 lone pairs on each oxygen. So 6, 6, 6, that's 18. And then the single bonds in the middle, that's another 6 for a total of 24. So right now, if you're subtracting, you only have 2 electrons left. So he adds the extra 2 electrons onto the lone pair, or sorry, onto sulfur to make sulfur happy, because now sulfur has 8 valence electrons as well, and you're out of electrons, so you're done. With polyatomic ions, the last thing you need to do, oh crap, I don't know if he's actually doing it. With cyanide, he didn't either. What you're going to do is you're going to put brackets around the whole thing, and you're going to add a charge, the charge on the top right. So with cyanide, you would put a charge of -1 on the outside of the brackets, and with sulfite, you would add a charge of -2. If you don't understand those directions, I totally understand. I don't have time to go back and like fix the videos or draw it myself. So what I'm going to do is I'll leave an answer key for you guys. There are answer keys. I'll leave them out, so if you'd like to take a look at how I did it, you can see. But you do need to add the brackets on the outside. All right, so we're done with sulfites, kind of. I want you to turn your sheets over, and on the back, I want you to work on the nitrite and the, what was the other one? Nitrite and carbonate ions. I want you to work on those 2 on the back of your notes from yesterday. It's the last 2 examples on the back of the page. I'll give you guys about 3 to 5 minutes to work on it. Go. I just realized I'm almost out of time on my recording, so I'm going to, Mr. Lane, if you could just let them work for about 2, 3 or 4 more minutes. I'm going to stop the video here, and then after the work time is up, if you could just show them my next video, please, and then that should get us through the rest of class. See you guys in a few minutes.